Hello friends, welcome to YouTube channel Electronics for You. Friends, in this video we are continuing the calculation of equivalent resistance. It's our part number 3, and especially in this video I will cover star delta transformation. In the star delta transformation we will see first the formulas required for star to delta transformation as well as delta to star transformation. So let us see first what is the star connection. Star connection or star network is also known as Y network or a star network also, or we can say that it is also called as T network. So you can see here that if we are having three resistances R1, R2, R3 and they are connected to form a common point, then such a network is known as star network. So this is the diagram for the star network. Here you can see see that a point is there which is known as star point, and three resistances R1, R2 and R3 are connected to this star point. Okay, and it is just making a shape just like a Y, that's why it is also called as Y network, or you can say that it is making a shape like a T, therefore it is also called as T network. So this is a star connection where we are having a point which is common to all this. This is called as star point. Another remaining points are A, B, C, which are called as line terminals here. So these are our line terminals. Now if the resistances R1, R2 and R3 are having the same values, that is R1 equal to R2 equal to R3 equal to R, then such a network is called as balanced star network. So this is our balanced star connection where R1, R2 and R3 all are having the same value. So this is our star connection. Now let us see what is the delta connection. So delta connection, as the symbol indicates, it is a closed loop. So we are having three resistances, and if they are forming a closed path, then such a network is called as the delta network, and it is shown here. So we are having three resistances R1, R2, R3. They are forming a closed path here, or we can call it as a mesh. So it is forming a mesh here, and this is our delta connection. Now the terminals A, B and C are also called as the line terminals again. And again, if R1 equal to R2 equal to R3 equal to R is there, means all the resistances are same, then such a network is called as balanced delta network, or we can call it as a balanced delta connection. So you can see here that all the resistances are having same value here. So this is our delta connection. Now the thing is that we can convert a star network into a delta network and vice versa. So let us see a star to delta transformation first. Now the first step is that draw the star connection with pencil. Now this is our star connection. I am drawing it with the pencil. We are having three resistances R1, R2 and R3. Now next step is to mark the line terminals. So we are having these line terminals there. I am marking here with pen now. Okay, and let it be the A, B and C respectively. Now our line terminals are also marked, and now we have to convert it into a delta network. So what I will do here, I will draw resistances like this and like this, so as to form a delta connection. So first resistance is this one. Let us draw it, and it will be replaced by a formula, that is R1 plus R2, means this resistance is having the equivalent resistance as formula for this is R1 plus R2 plus R1 into R3 upon R3. So this, as this is in between these 2 points, and let it be AB, and we are having this resistance R1 and R2 in between these 2 points. So the formula will be R1 plus R2 plus R1 into R2 over R3, that is the third resistance. Similarly, we can have the second resistance like this that is in between B and C. The formula is again same, that is similar, that is here R2 plus R3 plus R2 into R3 upon R1. Similarly, now you can guess the formula for the terminal AC here. The formula will be R3 plus R1 plus R3 into R1 over R2. So this is the required delta network which is drawn here with the pen now, and we in next step we will erase the pencil work, that is our star connection, and we will get a star to delta transformation just like this. Now important points to be remembered are: the neutral point will not exist after star to delta transformation is carried out. So here in star connection generally we are having a neutral point, but in delta connection we do not have any neutral point, so neutral point will not exist here if the transformation take place. And second point which is to be remembered is about the balanced star connected load. If balanced star connected load is there, the equivalent delta is given by 3. For example, we are having a star connection just like this, and we are converting it into a delta network, and if it is having, the star connection is having a resistance of 3 ohm each, then in delta connection we are having each resistance as 3R, that is 9 ohm. So we can convert a balanced star into a balanced delta by multiplying the 3 times the resistors of star network. So this is about the star delta transformation, and we have to remember these formulas. Now next is delta to star transformation, in which you can see here that again we are drawing the delta connection with pencil. So R1, R2 and R3 are drawn here with the delta connection by pencil. Now we are converting it into a star connection, so a neutral point will be there, and again the 3 resistances will join these 3 terminals, let it be A, B, C, etc. So here we have marked the line terminus here. Now we are having one neutral point just like this, and let the resistance is at this node. So this resistance is given by the formula R1 into R2 divided by R1 plus R2 plus R3. So this is the equivalent resistance which is in between the point R1 and R2. Therefore their multiplication in numerator divided by the addition of all the resistances in denominator. This is the formula for the star to delta transformation and equivalent resistance for this. Now second point, you can conclude again this resistance is given by the formula R2 multiplied by R3 divided by addition of all the resistances. Now you can guess which is the third point, which is nothing but the equivalent resistance for this, and it is given by R3 multiplied by R1 divided by addition of all the resistances. So this is the delta to star transformation, and again 2 important points are there. So this was the connection, and now erasing the pencil work we will get connection like this. Now important points to be remembered here: the neutral point is added, okay, and the balanced delta to star connection will be like this. This is R by 3. For example, a delta resistances is having value as 3 ohm, then each star connection, the required star connection will be R by 3, means only of 1 ohm, etc. So this is a star. This was about the balanced delta connected load. Now this was our delta connection indicated here by the dotted line, and we have converted this delta into equivalent star network, that is this one, by using these formulas. So this is our delta to star transformation. So in short, we can convert a star network into delta and a delta network into a star network just like this by using the respective formulas. Also in this figure it is just shown like this A B C, but if the figure is like this, then we can convert a star network into delta like this, or a delta network into star just like this. So here you can see here that the point C was over here and it will remain as it is, and AB is at this will remain as it is. Only the thing will be the equivalent formulas. In next video I will explain some problems of star delta transformation, so keep watching. Thank you. And friends, if you like this video, please subscribe our channel and press the bell icon for notification, and like, comment and share. Thank you.